Welcome to this introduction demonstration of the automated deployment of Refinitiv real-time connector on Azure. This demonstration will provide a brief overview of the Azure components that the automations deploy, how these interact to provide the solution, and how the solution can be extended to meet the requirements of specific customers. The first slide provides an overview of the Azure components deployed to support the deployment of the real-time connector solution. Some of you will notice that the DAX software component is not shown on this diagram. However, this is fully supported on Azure. It's just not included in the automations being demonstrated at this time. The main RTC components are deployed onto an Azure Kubernetes cluster, in which we run RTC pods containing the RTC container. Currently, we leverage the Refinitiv real-time image from Docker Hub, a metrics container using Telegraph, an open source capability that allows us to capture metrics from RTC using the REST APIs that are available and send this to a target metrics store. There are many options available using the Telegraph plugins, but the solution included in the automations today leverages Azure Data Explorer. You will see how this data can be represented in an example dashboard later in this demo. As part of the automated deployment, we also deploy a demo tool server or test server to allow the simulation of upstream data, optionally a test client to simulate the connection of applications, and a reporting virtual machine which allows us to run our dashboarding solution. So that's a brief overview of the solution. Let's take a quick look at what this means in more detail for the deployment options you'll see later, and how this can leverage the Azure capabilities to improve resiliency and scalability. As part of the automations you'll see demonstrated later, we currently offer two different deployment models. The test deployment, which you can see on the screen here, will deploy a single cache pair across two Azure availability zones to improve resiliency, with warm standby configured between the caches, which is enabled through the RTC configuration. Two RTC fanout pods are deployed, again in different availability zones to support client connectivity via the Azure load balancer, deployed as part of the Kubernetes cluster. Upstream connectivity to the test server is automatically configured from the RTC cache layer, essentially allowing us to simulate data passing through the solution. We also provide what we've termed a demo deployment. This provides some additional capabilities over and above the test deployment. Again, we're running a cache layer and a fan-out layer, but this time we have a pair of caches in the cache layer. So the 0 caches and the 1 caches are paired with warm standby between the two, split based on hash IDs. You can see in the diagram the fan-out pods connect to all the caches. So if there's a failure at the cache layer, the fan-out layer carries on without any issues, leveraging the warm standby capability. On the right hand side of the diagram, you can also see that we can scale this solution as required. To scale the cache layer requires some slight changes to the fan-out configuration. However, the fan-out layer is fully scalable horizontally, and we can scale that out into availability zone 3 if we require, or we can just scale inside the availability zones, provide more resilience and scalability. Adding additional fan-out scaling has some implications with how the RTC solution works, particularly for scaling. We will cover that in a different demo and the impact of scaling out and scaling in the fan-out layer on the RTC solution. Hopefully that covers a brief introduction to the architecture, what you're going to see deployed today and how the components interact. We'll now move on to see how this can be done from an automated deployment on Azure and demonstrate the capability once that's been deployed. You can see the custom deployment wizard, which takes you through a few simple steps to allow me to deploy RTC on Azure. So I can select the subscription I want to target. I can create a new resource group into which I'm going to deploy these resources. I can select the region I'd like to deploy into. So we have a number of regions listed. If I click to next, I'm through into the networking configuration. I'm going to leave this the same for the purposes of this demo. And then I'm into the RTC options that I can select. I can pick how I want my Azure resources to be prefixed, the type of deployment I'd like to select. So I'm going to pick demo in this case. I can pick the software version I'd like to deploy. So I'll pick the latest one, 3.6. I can pick the license file required. For the purposes of deployment on Azure, you need a non-node lock license. I have two options for Kubernetes networking. These are standard options within Azure Kubernetes service. So I'll leave the default Azure-based model. And then upstream connectivity. Do I want to provision a test server for demo simulation? And do I want to provision a test client for simulating client connectivity to RTC? So in this case, I'll say yes to both of those. If you had RTO upstream connectivity, you could select RTO here, but that would require some additional configuration options. I then give it the Azure credentials that I need for connecting to any of the virtual machines I'm going to deploy. So I'm just going to pick a key that I already have stored in Azure. And then do I want to capture any RTC metrics? So by default, we use Telegraph to extract metrics from the RTC REST API and send those to Azure Data Explorer if you select metrics. If you don't select metrics at this stage, we won't provision Azure Data Explorer or any other metrics capture resource. I'm going to say yes to this, and you can see I can pick Azure Data Explorer, or I could pick InfluxDB. We don't provision InfluxDB. It just provides the ability to provide the credentials and the URL to connect to InfluxDB. Our standard is Azure Data Explorer, so I'll leave that as is. I could add some tags if I wanted to add some tags to the deployed resources. Then I get this review and create option. It should come up after completing the validation as validation passed. I hit create, and it will start deploying these resources into my Azure subscription. Fully automated, nothing else to do at this stage. If I switch across to one of the resource groups that I've already deployed this solution into, what we'll see is we can see all of the resources are deployed. So you can see here examples of the Azure Data Explorer cluster. I've got my Kubernetes cluster. I've got some VMs that are used to support different parts of the solution, all deployed into that resource group. So whilst that's deploying, I'll have a look at this existing example. And as I mentioned, we deploy Azure Data Explorer to capture the metrics. I have a Grafana dashboard configured with that. So here's my Grafana dashboard. And you can see at the moment, there's not much going through this. There's probably some historical data here left over from a test, but there's nothing going through the cache pods at the moment, nothing going really through the fan out node, no metrics showing up here. So what I can now do is I can say, let's take a look at the cluster. And this should show me what I've just seen in the dashboard. So my cache instances and my two fan out instances. And then I can connect to the tooling server, so my test client and my test server. And what I can do here is I can actually kick off some simulated tests. So you can see test server here is started up, sending some updates. I'm going to connect with two clients from test client. I'll kick those off, and so you can see both. So now I'm getting updates sent in from test server, being processed by RTC, and then being consumed by the simulated test client. So now when I go back to my Grafana dashboard, pretty soon you can start to see I'm seeing load coming through the different instances. So it'll take a couple of seconds for this to start to refresh. But what we should start to see is if I pick onto the aggregate view, you can start to see metrics being populated into the dashboard, the incoming update rate. And as this grows out, what we'll start to see is, there you go, all of the cache nodes picking up the same amount of data. And you can now see this is showing effectively I've got 4 clients connected because I had 2 previously, and now I've added the 2 additional ones with test client, and those are consuming. You can see in this case, it just so happens they're all on the same pod. But if you had more clients, they would balance out across the 2 fan out nodes. If I go now back to my Azure deployment, I should be able to see where I've got to with that deployment. So it's still running. You can see here the resources automatically dropping out to Azure. Once this is deployed, there's a simple setup script to add the Grafana configuration, which automatically adds the dashboard and the data sources for you. We combine metrics from not just from RTC, but we also combine some operational metrics from Container Insights. So in the actual dashboard solution, as well as seeing RTC metrics, RTC logs, You also get operational metrics from Container Insights shown in here in case there was anything you wanted to see regarding the cluster. But that's all deployed automatically for you through this one-click deployment process. It takes about 5 minutes to run, beginning to end, but that essentially deploys everything you need to get up and running with RTC on Azure. There's some additional configurations which would be required if you were going to use DAX or ATS, but this gives you a sample deployment which you can run with test client, test server to simulate data and get familiar with the deployment model.